Hey guys, welcome back to geometry. Last couple of times we were together, we were looking at proving segment relationships. Well, now we're going to look at proving angle relationships. A lot of the properties that we're going to use are the same. Okay, so for instance, we have these first 5 properties that we had last time for segment proofs. We're going to be using some of them for the angle proofs as well. Okay, now obviously segment addition postulate deals exclusively with segments, but the reflexive property says that a segment is congruent to itself. Well, it also works for angles. We can say that an angle is congruent to itself. The symmetric property said that if we have segment AB is congruent to segment CD, then that means that segment CD is congruent to segment AB. So we can flip those statements over the congruent sign. Well, it works exactly the same for angles as well. If angle 1 is congruent to angle 2, then that means angle 2 is congruent to angle 1. Okay, we can flip it over that congruent sign. The transitive property works very similarly. If I have segment AB congruent to segment CD, and segment CD congruent to segment EF, then I can cut out that middleman. Both segment AB and EF are congruent to the same segment CD. I can cut out that segment CD and say that AB and segment EF are congruent to one another. We can do the exact same thing with angles. If I have angle 1 and angle 3 are both congruent to this angle 2, I can cut out that middleman and say angle 1 and angle 3 are congruent to one another. Okay, then we had the midpoint theorem. The midpoint theorem, again, deals exclusively with segments, but the angle addition postulate sounds a whole lot like segment addition postulate, and it's really similar to the segment addition postulate. Okay, what this basically says, if R is in the interior of angle PQS, so here in blue, I've got angle PQS, and then I've got R here in the interior, then that means the measure of angle PQR plus the measure of angle RQS is going to be equal to the measure of angle PQS. In other words, one piece plus the other piece is going to be equal to the whole thing. Okay, so just like the segment addition postulate, we have the angle addition postulate. Basically, if I split an angle into 2 parts, I can add the measures of those 2 parts together, and that will be equal to the measure of the whole thing. Okay, then we've got supplementary angles, and we've talked about this in the past. Supplementary angles are just angles whose measures add up to 180 degrees. Complementary angles, very similar, are angles whose measures sum to 90 degrees. Now these are similar names, and they have similar meanings. But the easiest way to keep these two straight as to which one's which is remember that complementary would come first in the dictionary, and 90 comes first on a number line. Okay, so it's kind of in alphabetical order. Then we have the supplement theorem. Okay, now the supplement theorem is not the same as the definition of supplementary angles, so make sure you use the right one at the right time. The supplement theorem says that if 2 angles form a linear pair, then those 2 angles are supplementary. So take a look at this diagram. Angles 1 and 2 form a linear pair. They are adjacent angles whose non-common sides form a straight line. So since angles 1 and 2 form a linear pair, angles 1 and 2 are supplementary. Okay, then we have the complement theorem. Okay, and the complement theorem states if the non-common sides of 2 adjacent angles form a right angle, then those angles are complementary. It's basically the same thing as the supplement theorem, except with complementary angles. Okay, angles A or BA, let me try this again. Angle ABC. If that's a right angle, okay, then the non-common sides of angles 1 and 2, okay, side AB and side BC, those form a right angle. What that means for us is that angles 1 and 2 have to be complementary. They have to add up to 90 degrees. And that makes sense. If we look at the diagram and see that these 2 sides on the outside of this pair of angles is a right angle, then if I add these 2 together, I've got to get 90 degrees. Okay, then we have the angle bisector. Okay, and the angle bisector is a ray that divides an angle into 2 congruent angles. So here we've got angle ABC, and I've got ray BD drawn right down the middle. Now, if I tell you that BD bisects angle ABC, then that means that angle 1 has to be congruent to angle 2. So bisect means cuts in half, so that makes perfect sense. If it cuts it in half, then those 2 halves have to be congruent to one another. Okay, let's look at a couple more. If 2 angles are vertical angles, then they are congruent. Well, we talked about what vertical angles were way back when. If we look at this diagram here, vertical angles are angles formed by 2 lines who are non-adjacent. So angle 1 and angle 3 would be vertical angles, and those 2 angles are going to be congruent. Angle 2 and angle 4 are vertical angles, and they are going to be congruent. Now, back when we were talking about congruent angles and linear pairs and supplementary and complementary earlier on in the year, we told you that vertical angles are always going to be congruent. Well, now we have a property that backs that up. Now down here we have what I'm calling the nameless properties. These properties don't have a name to associate with them like the vertical angles theorem, but these are properties that are going to be true. However, before we can use any of these properties in any of our proofs, we have to prove that they have to be true. So here I have angles supplementary to the same angle or to congruent angles are going to be congruent. Angles complementary to the same angle or congruent angles are congruent. So these are very similar properties. Let's see what we can do about proving. Okay, so number 1 here. I have angle 1 and angle 3 are complementary. Angle 2 and angle 3 are complementary. So here we have angle 1 and angle 2 are both complementary to that same angle 3. What I want to prove is that angle 1 is congruent to angle 2. So this is one of those nameless properties, and if I prove it, then I can use that property as a step in other proofs. So I need to start out with the given information. So I list that, and I say that it's given. And honestly, guys, at this point, that should pretty much be automatic. You know that your very first statement is going to be the given information, and you know your very first reason is going to be that it is given. Then, statement 2. I have the measure of angle 1 plus measure of angle 3 equals 90 degrees, and measure of angle 2 plus measure of angle 3 equals 90 degrees. Now, it's not just about what property looks like this line, it's about what property allows us to get to this line from previous lines. So first I say those pairs are complementary, and now I say I add those angles together and I get 90 degrees. Well, that's what it means to be complementary angles. That's the definition of complementary angles. Then I say that measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3. So I need to figure out how I can get this equation from these previous equations. Well, both of these are equal to 90 degrees. That's going to allow me to say that they're equal to each other. We're cutting out the middleman of 90 degrees. And the property that says we can do that is the transitive property. Okay, these two sums are both equal to the same thing. That means that these two sums have to be equal to one another. Okay, then I want to look at how I'm getting from line 3 to line 4. What's different? Well, I've got measure of angle 1 plus measure of angle 3. Okay, I got that right here again. And I have that equal to measure of angle 2 plus measure of angle 3. And here I have that again. So what's different is I'm subtracting that measure of angle 3 from both sides. The property that says I can subtract something from both sides is the subtraction property of equality. Okay, then what changes is measure of angle 3 minus measure of angle 3 goes away, and I just have measure of angle 1. And then measure of angle 3 minus measure of angle 3 goes away again, and I just have the measure of angle 2. So what allows me to simplify that subtraction is the substitution property. And then finally, I change from an equation to a congruent statement. Instead of saying that the measures of those angles are equal, I say that those angles are congruent. And that is the definition of congruent angles. So we've gone from saying that these two angles are both complementary to the same angle, and now we're saying that those two angles are congruent to one another, which is what we set out to prove. So we can say QED, quote expecto demonstratum, and our proof is finished. Now, that nameless property that we talked about last time, or on the last slide, angles complementary to the same angle are congruent. Now, this can be a statement in further proofs. So if I have a situation where I have the two pairs of angles, or excuse me, two angles are complementary to the same angle, I can skip all of these steps and just say that angle 1 and angle 2 are congruent because angles congruent or complementary to the same angle are congruent. So that allows us to shorten our proofs later on down the line. Okay, next up. Okay, very similar. I have angle 1 and angle 2 are supplementary. So 1 and 2, supplementary. Angle 3 and 4 are supplementary. And what I want to prove is that angle 1 is congruent to angle, I have also that angle 1 is congruent to angle 4. I want to prove that angle 2 is congruent to angle 3. Okay, this is what I'm setting out to prove. So we always start with our given information, and we always know that it's going to be given. Now, every once in a while, depending on who the author of the proof is, they might split these up into 3 different statements. These are all our given information, so I like to put them all out there all at once in one statement and say the reason for all of that information is that it's given. I feel like that shortens the proof a little bit. Now, I go from saying that they're supplementary to saying that their sums are equal to 180 degrees. 1 and 2 are supplementary. Measure of angle 1 plus measure of angle 2 is 180 degrees. Angle 3 and angle 4 are supplementary. Measure of angle 3 plus measure of angle 4 equals 180 degrees. Guys, that's the definition of supplementary angles. If we say that they're supplementary, that means that their measures sum to 180 degrees. Now, to get from statement 2 to statement 3, look at how it's changing. Okay, I have measure of angle 1 plus measure of angle 2, and I have that here. And I have measure of angle 3 plus measure of angle 4, and I have that here. So now instead of saying that they're each separately equal to 180 degrees, I now say that they're equal to each other. The property that allows me to cut out that middleman is the transitive property. Now, seemingly out of nowhere comes measure of angle 1 equals measure of angle 4. And our first thought might be, well, if we look at the previous step, measure of angle 1 comes from here, and measure of angle 4 comes from here. So we're getting rid of measure of angle 1 and measure of angle 3, and we have to be subtracting them away. But if I'm going to subtract these away, somewhere in a previous statement, I need to say that these two are equal to each other. And I don't know that. As a matter of fact, that's what I'm trying to prove. So it can't be the subtraction property of equality that lets me say this. Okay, so I need to think of another way to get here. Well, the important thing to remember is when we're talking about geometric proofs, we're not just getting from one line to the next line. We're getting from all of our previous lines to the current lines. So look at all the previous information, and we see right here, we have angle 1 congruent to angle 4, and now I'm saying that their measures are equal. The property that's going to allow me to make that change is the definition of congruent angles. By saying that they're congruent, that means that their measures are equal. Now their measures are equal. Take a look at what happens right here. Okay, I still have measure of angle 3 plus measure of angle 4, and I still have measure of angle 1 plus measure of angle 2, but here I'm subtracting measure of angle 1 from this side and measure of angle 4 from this side. So now I'm subtracting the same value from both sides of the equation. The property that says we can do that is the subtraction property of equality. Then we simplify what we have here. We cancel those measure of angle 4s, we cancel those measure of angle 1s, and we have measure of angle 2 equals measure of angle 3. And what allows us to simplify that is the substitution property. And then finally, I go from saying that their measures are equal to saying that the angles are congruent. And what allows me to make that change is the definition of congruent angles. So with each of these guys, just a reminder, it's not about what property looks like that line, it's about what property allows us to change from previous lines to that line. So focus on how you're changing from one line to the next and think about what property justifies that change. All right, let's take a look at just a couple more. Okay, now these ones are all completely blank. So we need to think about a strategy on how we're going to get from where we're starting to where we want to end up. Well, something also to keep in mind, sorry I missed it here, we just proved something. We proved that if two angles are supplementary to a pair of congruent angles, angle 1 and 4, that means those two angles are congruent to one another. Well, guys, that's one of our nameless properties. That's this very first one. Angles supplementary to the same or congruent angles are congruent. So now we can use this as a reason in later proofs. Okay? All right, so let's take a look at this one. Okay, so like we said, I have angle 1 and angle 2 form a linear pair. So here's angle 1, here's angle 2, they form a linear pair. And I also have the measure of angle 1 plus measure of angle 3 is 180 degrees. So what I kind of see is that both angle 2 and angle 3 are both supplementary to this angle 1. And I want to prove that 2 is congruent to angle 3. Well, guys, that's like that property that we just proved. Angles supplementary to the same angle, or two congruent angles, are congruent. So what I need to say is that both of those angles, angles 2 and 3, are both supplementary to angle 1. If I say they're both supplementary to angle 1, then I can say they're congruent to one another. Well, we know we're always going to start with the given. Okay, and we know that our reason is that it's given. Now, from saying that these two form a linear pair, okay, saying that they're a linear pair is not the same as saying that they are supplementary. But I can make the jump and say that they're supplementary because of the supplement theorem. Angles that form a linear pair are supplementary. So now I have angle 1 and angle 2 are supplementary. What I need to say now is that angle 1 and angle 3 are supplementary. Well, if they add up to 180 degrees, then they have to be supplementary because that's the definition of supplementary angles. So now I have angle 1 and angle 2 are supplementary. Angle 1 and angle 3 are supplementary. So these two angles are both supplementary to the same angle. And like we just said, angles supplementary to the same angle are going to be congruent. So I can say angle 2 is congruent to angle 3, and this proof is finished. Okay, one more. Here I have segment AB is congruent, or excuse me, perpendicular to segment BC. Angle 1 and angle 3 are complementary. Okay, and I want to prove that angle 2 and angle 3 are congruent. Now this is very similar to the one that we just did. We'll start out by listing all of our given information. Segment AB is congruent to segment AB is perpendicular to segment BC. Angle 1 and angle 3 are complementary, and I know that the reason for that is that it's given. Now, just like last proof, what I need to do is say both angle 1 is complementary to angle 3, which I already have, and angle 2 is complementary to angle 1. If I can say that both 2 and 3 are complementary to angle 1, then I can make that final step to say that angle 2 is congruent to angle 3. Okay, so that's my strategy. Say that they're both complementary to angle 1, and then I can say that they're congruent to each other, saying that angles complementary to the same angle are congruent. So really, I've got my given. I know how I'm going to get to where I end up. I just need to get there in the middle. Well, by saying that these two lines are perpendicular, that means that angle ABC, right here, is a right angle. Okay? And if I have that it's a right angle, I have that it's a right angle because of that definition of perpendicular lines. Perpendicular lines form right angles. Okay? Then, if that's a right angle, angle 1 and angle 2 are adjacent angles. And if they're adjacent, okay, and these non-common sides form a right angle, that means that these two have to add up to 180 degrees. They have to add up to 90 degrees. And that's exactly what one of our properties says. Angle 1 and angle 2 are complementary because of the complement theorem. They're adjacent, and their non-common sides form a right angle. That means that they have to be complementary. Well, I've got angle 1 and angle 2 are complementary. Angle 1 and angle 3 are complementary. So since angle 2 and angle 3 are both complementary to the same angle 1, that means they have to be congruent to one another. Because angles complementary to the same angle are congruent, we've proved what we set out to prove. So when we're trying to write a proof, okay, first off, take a close look at what we're given, take a close look at where we want to end up, and come up with a little bit of a strategy that you can use along the way. What's really going to help with that is this list of properties, okay, the nameless ones, as well as all of these that we talked about at the beginning. If you know these off the top of your head, that's going to be very helpful for you. If you don't have to memorize them, though, you can just have that paper with you. But having those properties either in your head or in front of your face is what's going to make everything go a whole lot smoother. Come up with a little bit of a strategy of how you can make that proof happen. Focus on how you're changing from one line to the next and think about what property allows you to make that change.